Good morning, students. So this one is number system exercise 1.3. Number system exercise 1.3, question number 6. So there is written what? Look at the several examples. Look at the several examples of rational numbers in the form p by q, where q not equal to 0, where p and q are integers with no common factors other than 1 and having terminating decimal representation. This one is the main point. So terminating decimal representation. So numbers which are having terminating decimal expansion, that numbers you can express in p by q form, that numbers you can express in p by q form, and q, that means that denominator, is expressible in the form of 2 to the power n into 5 to the power n. You remember this one. Okay, numbers or rational numbers which can be expressible in the form of p by q. Okay, so q and it has terminating decimal expansion, then q, that means denominator, you can express in 2 to the power n into 5 to the power n. And what is written in the question, you see, can you guess what property q must satisfy? Can you guess what property q must satisfy? What is the property? Property means q has prime factor 2 and 5, because this number or some numbers which are having terminating decimal expansion, that number can be expressible in the form of p by q, where q can be expressible in 2 to the power n into 5 to the power n. And what property is satisfied by q? Q has prime factors 2 and 5. Q has prime factors 2 and 5. It is the property. Okay. So we have written numbers which are having terminating decimal expansion can be expressible in p by q form and q not equal to 0, where q can be expressible in the form 2 to the power n into 5 to the power n. So q has prime factors 2 and 5. That's all. So this problem already finished. Now we see question number 8. Question number 8 written, find three different irrational numbers between the rational number 5 by 7, 9 by 11. So already given these two numbers are rational. Already given these two numbers are rational. So if these two numbers are rational and we need to write three irrational number. We need to write three irrational numbers. There is written three different irrational numbers between these two numbers, but these two are rational numbers. These two are rational numbers. Okay. So first of all, we have to divide. Find out the decimal expansion of 5 by 7 and find out the decimal expansion of 9 by 11 by division method. So just I have divided. This one also dividing. So here you see, this 5 is again repeating here. Divide already you know. So just to divide it, 5 is again repeating or not? 5 is again repeating, means these all the steps again it will repeat. That means 7095 285 1 2 3 4 5 6 7 digit, total 7 digit, again it will repeat. That means it is non-terminating and repeating decimal expansion like this one also. See, again this 9 is again repeating here also repeating. So this one also non-terminating and repeating decimal expansion. Now we have to write between these two numbers, we have to write irrational number, and by the definition of irrational number we know numbers which are having non-terminating and non-repeating decimal expansion. That means we have to write three non-terminating and non-repeating decimal expansions between these two numbers. So first of all you write down this. So 5 by 7 equals 0.7095285 dot. Then next one is 9 by 11 equal to 0.81 dot. many are there. Okay, now we have to write between these two numbers. We have to write the three. We have to write the required three irrational number. Required three irrational numbers between 5/7 and 9/11. So between these two, if you consider 7 and 8, so between 7 and 8 no number are there, so we can consider 70 and 81. So between 70 and 81 there will be 71, 72, 73, 74, like that, many are there. So by considering after 70, next is 71, by considering 71 we can write one non-terminating and non-repeating decimal expansion. So that one just like this. So 071, 071, 0071, 00071 dot. Like this, by placing 0, just you imbalance it. Okay, so see 0, 1, 0 given here, 2, 0 here, 3, 0. So you write down in imbalance manner by considering 71, or you can consider 709. After 709 there will be 710, 711, 712, 713, like that, many are there. Anyone just to consider, and this way just to write. Next one is what? 71. After 71, 72. So 0.72, 0.72, 0.072, 0.0072, like that. After 72 you can write 73 wise, 73, 0.73, 0.073, 0.0073, like this. Three non-terminating and non-repeating decimal expansion we have written. Many you can write, infinitely many irrational number are there between two rational numbers, and that way you can solve this problem. That's all today, this much.